So real quick, there's one more way that you can write sets that are it's fine and all formal and stuff like that. And the way you do that is you kind of use the form. I'll write it up here. You kind of went over this already. Another valid form goes like this. So saying that A equals the set of X and D such that P of X is true. We could also write that as A, actually forget X and D set. We can write a set as some transformation of X such that X is in D and some P of X is true. And this looks weird. That's because we need to do examples. We're at the bottom of the circle. We're going to the top of applications. So in this case right here, this is really a long-winded way to write this. Because we say n's a natural number such that n equals 4k plus 1 for some k and z. Well, as long as k is greater than or equal to 0, 4k plus 1 is going to be a natural number guaranteed. So we're kind of just saying more than we need to. We're not over constraining our system, but we're just kind of being a little redundant. And so maybe a better way to write this, the way I would write this in the real world in real math, the way I'd write this is I'd say this equals 4k plus 1, the set of all things that have the form 4k plus 1, such that k is in z and k is greater than or equal to 0. That's basically how I'd legitimately write this. In some math research or whatever you're doing in like real math. And so this first part, right, is kind of like the form of the number you're talking about. And this part restricts your variables to particular things, whatever you want. So another option, if you had t equals the thing we had t equal 4, 1, 2, 3, 5, 8, 13, 21, on like that. How'd you guys write that in this new kind of notation? Well, the way you think about this is you just go, what is everything in my set? Like rather than beating around the bush and saying like, oh, what's the general set that my elements are in, and then specifically what kind of elements they are. I mean, that's what this is, right? You say, okay, generally elements of my set are natural numbers, but specifically they're this.
And you just write in like the sequence definition such that the range is valid.
Yeah, or I mean, sorry. We would always have f defined. So we'd have like f of 1 equals 1, f of 2 equals 1, f of n equals f of n minus 1, plus f of n minus 2 for all n greater than or equal to 3. So yeah, the definition, you just go, okay, well, what's everything in my set? Everything in my set's a Fibonacci number. Okay, so they're all Fibonacci, so it's a set of all Fibonacci numbers such that n comes from it. What am I doing? What am I doing? We're past this. There we go. So yeah, so both ways of writing things, like this or like this, totally valid. It's just whatever one's easier, honestly. Sometimes the reason one would be easier is because sometimes it's hard to pinpoint where like Fn or where this transformation will be. It's sometimes hard to pinpoint where that'll be. And it's easier just to say how you build it from things over here. So you build f of n from natural numbers, but just subscripts. You build this from this by multiplying by 4, adding 1. It's kind of like that. But both are fine. All right.